Hello everybody. In this video I will demonstrate you how you can test your lectron legacy transistors in an easy and safe way. The transistors used in these sets are made of the crystal germanium, which is completely different from modern silicon transistors. The transistors, like this is one of an example, has three connections: the collector, the emitter and the base. So when a transistor is working and without the base connection connected, this is an open circuit, which means the transistor is not conducting. But when we apply a voltage at the base, then you will see that the transistor starts to conduct. This is the way we can test the transistor. Like here we have a setup. So what we have is the battery is connected with the plus to the ground or the chassis. The minus is connected via this resistor of 1.5K to the collector of the transistor. Emitter is grounded to the chassis. Now, to adjust the base voltage, we need a control. So I have a potentiometer here. This time, this potentiometer is completely counterclockwise at this moment. The voltage comes through this 10K resistor to the potentiometer. So when we start rotating, we will add more or less voltage to the base of the transistor to test it. I have also added a silicon diode here. This diode has a property: when it is conducting, it has a voltage drop of 0.7 volts. This is not needed exactly, but it makes it easy to adjust in fine steps the base current. Okay, now to start, we have, so as already said, the potentiometer is completely counterclockwise and the meter is showing about 9 volts, which is the battery voltage. When you see here at the schematic, you can see that the transistor is blocking. So there is no current flowing from the emitter to the collector, and the meter shows it since this is connected to the collector. Now when we start rotating, you will see that the meter starts to drop. This is a normal behavior when a transistor is working. If you would not see this behavior, then you would know that your transistor is defective. So if we set it back to completely counterclockwise, the meter is still reading the battery voltage. If you would notice that your meter reading is less or even 0 volts than the battery voltage, then you know your transistor is also defective. But let's set it here at the halfway for the 4.5 volts. That's more. So now we have set our transistor at halfway the battery voltage. We will measure at the collector 4.5 volts. So we know that the transistor is halfway conducting, halfway blocking the current. If you would not see this, then you know the transistor is also defective. We have different transistors in the legacy set. We have the one with the 680K and 100K resistor built in. We can use also this setup to check. So we will remove, set first of all counterclockwise. You move count block here, move the transistor. Then we will test, for instance, the one with the 100K resistor. Like this. You see also that's the battery voltage of about 9 volts. But you see the reading is a little bit different from the one with 330K. This is also normal because you have also noticed there is a resistor connected from the collector to the base. So it makes it conduct. Since the 100K resistor is lesser in value than the 330K, the transistor is a little bit conducting. So now when we start rotating, you also see that the meter starts to deflect. The way it deflects depends on the amplification factor of the transistor. So let's now test the 680K. This is the 680K transistor. Put it back. So we have here 9.979 volts, which is even more than the 308 cases, because the 680K is very large in value. But now we start rotating, and you see that also voltage drops. So now you know the transistors are working and they are good. You can use them. Thank you very much for your attention. Bye.